Hello, everybody. Welcome to Portfolio Optimization Part 2. In this part, we want to optimize a portfolio which includes three different stocks. What does that mean? It means we want to select three different companies, download their data from internet using Excel, and then we want to adjust the weights of these three different stocks in our portfolio in a way that for a given level of risk or standard deviation of portfolio, we get the maximum return. Let's get started. Let's do it. I'm gonna share my screen with you, and here we go. And we are gonna just start from scratch. Yes, the I'm gonna start from a blank page. Now, let's see. For in order to do this, we need a start date from what time we want to consider our portfolio, and end dates and different stocks. So start date can be, let's say, I don't know, if we focus on a 10-year time period, we can start from, for example, 2015, January 1st, all the way to 2024, December 31st. It's 10 year. Oops. Let me rather than underscore. Yes. Okay. And then we want to pick three different stocks. So we're going to focus on, we're going to use their tickers or their symbols. Yes. I'm going to choose like three very famous companies. Let's say Tesla is very trendy. TSLA is the ticker. If you don't know the ticker or the symbol for these companies, you can just Google them, or even you can find them on Excel. Uh, Using stock in data, but essentially you can, or if just Google something like Tesla stocks, and the very first thing that comes up is the ticker. The second company is Coca-Cola with the ticker KO, and the third company can be like Apple, AAPL. So we have 10-year periods and we have three different tickers, companies, and let's get started. Yes. In order to download the data, we are going to start from something called stock history. So as soon as I put the equal sign and I do this stock history, I can just double click on it, and then it needs bunch of variables, like bunch of information it's asking us. The very first one is stock, which is the ticker. I put a comma. Then is start dates right here, end dates right here. Next one is telling me interval. What is that? So let me just put a number, for example, like 0, and it gives me these three options. 0 means daily, one, I should insert 0 for daily, 1 for weekly, and 2 for monthly. So if I want to download the weekly data, for example, I put 1. In order for a portfolio optimization, it's industry standard to do monthly data. So I'm gonna delete this 0 and put 2 because I need monthly data. And then headers, I'm gonna put 1 because I want the headers to be shown. Next one is property. I don't know the properties. Let me just put a number like 0, and it shows me all the options. Dates. Yes, for the first one, for Tesla, I want the dates to be shown. So I'm going to put 0, and then I'm going to put comma. What else I do need? I need the closing prices. I don't need the open. I don't need high, low volume. I just need the closing data. So, and that's all I need. So I'm going to close the parentheses and hit enter. And boom, we got the data for Tesla. Yes. So it's monthly data, like January 2015, February 2015, March 2015, so on and so forth. And I get the headers, which is data and close. And the close data is adjusted for stock split. That's perfect. Next, I'm going to do KO. So one more time, I'm going to type equals stock history. And then I could also just copy and paste the formula that I had, but for instructional purposes, I want to do it again. So I'm going to click on this, put a comma, start date right here, end date right here, intervals, monthly, headers, one. Now I don't need dates anymore because the date would be the same for Tesla, Coca-Cola, and Apple. So all I need is just closing prices. And I close the parentheses, hit enter, takes a few seconds. And every now and then you might get an error like this, yes, which is absolutely fine. Just try again. And then you should be able to get this if you are connected to internet, which I am. Every now and then, unfortunately, you get this hashtag connect simulation part, and but if you try it like other times, you should be able to get it. But right now, let's try for Apple. Let's see if we get data for Apple. For Apple, we got it. For Coca-Cola, we are not getting this. Oh, here we go. We got it. So I got the data. You see, I just did it again and again. And unfortunately, sometimes something like that happens. But what I got is the data for Tesla, Coca-Cola, and Apple monthly data. Yes. So monthly data for Tesla, Coca-Cola, and Apple. And I got it for 10 years. So 120 rows. Yes, 120 rows all the way to December 2024. And like Tesla started from, let's say, $13.57, and it went up all the way to $403.84. Coca-Cola started from $41.17, went up all the way to $62.26, and Apple started from 29.29, and it went up to 250 and 42 cents. Perfect. Now that I got my data, I can start doing the next phase. So before that, let me just copy and paste everything, all the data. I want to copy this. And then here on another tab, for example, I can call this price. Yes, this table, I can call it price. And so I'm gonna just copy this and I'm gonna paste it as paste special. So you gotta right click, which on uh, Mac is like control click, just paste and then paste special as values. I want them to be just numbers, yes. And then I got the date. I need the ticker, so I'm going to just copy and paste the tickers from here as well. And on this tab, So I got all the tickers. I have all the dollar signs here. I'm not very happy, not a big fan of this dollar sign here. So just quickly, I'm gonna select everything and then I'm gonna go to tab home and change general to numbers. And boom, I got rid of the dollar signs. So I got a table of the price of these three companies for Tesla, Coca-Cola, and Apple, and monthly data for 128 books. Next thing that I want to do is to calculate the price changes. So the name of this table is price change. And the first column is going to be the same thing, dates. So I'm going to just copy and paste this column over here. Then I need the titles for these three. So I'm going to just call this Tesla underscore R, like rate, yes, how much it changed from 1 month to another in percentage term, yes. So essentially, I want to calculate what percentage Tesla stock or Coca-Cola stock or Apple stock went up or down, like from January 2015 to February 2015. So what's the formula? So first of all, we can't calculate those numbers for the first row because we do not have the data a month before January 2015. We don't have data December 2014. So you have to leave the first row blank. Here, I can just type something like this, equals, and then second one minus first one, and then divided by initial one. However, I want the data to be reported as a percentage. So I'm going to just say equals 100 times this guy. And I hit enter. I go back to that point and I double click on the filler points and I get all of these data. Like here we are saying that here it went down like 0.127%. Next month went down 7%. And then next month went up 19.7% for the Coca-Cola. And I can just drag this to right and then go back here, click on the filler points. Filler points, you see this small green point over here. That's called filler points. And you see like this plus becomes a little bit different when I go that over it. I can also just drag it and go all the way down. That also works. So that's one way. Or I can just double click on the filler point. That also works, both of these. So in this table, I calculated the price change. Now, before doing the next thing, I want to name these three series, the changes, yes, because I want to use these later on. So I'm going to select all the data for example, here, Tesla, and then go right here and call it TSLA underscore R. Hit enter. So now this series is called TSLA underscore R. And then this one, I'm going to select the whole series and then go right here and then call it KO underscore R. And then the same thing for this one. I'm going to select these series. You must do this for one of the steps, so it's essential part. I'm going to just go here, call it AAPL underscore R, and boom. Now, I named all of these series. Now, next table I want to create is a table for averages and variances. So this is the table that I want to create, and we have, as always, three different stocks. So the first thing I want to calculate is monthly average. Yes, AVG. So rather than AVE, I'm going to say AVG. So I want to calculate the monthly average of this. So how do we calculate monthly average? With keyword equals average, yes. And then I can either just select this series, go all the way down. Oops, not this much down. All the way to here. However, if you do that, just Excel, since we call that series TSLA underscore R, Excel is going to just call its name and close the parentheses and hit enter. And then I can just drag it to right and then change the name from TSLA to KO, or you could easily just select the data and then calculate the averages. So here we know that the monthly average for Tesla is percentage change for each month. That on average, it went up 4.3, Coca-Cola 0.45, Apple 2.1. Good. If I want to calculate, let's say, monthly variance, how do I do that? So the formula for variance is equals, and if you type just VAR, it gives you var.p, var.s. For the most part, we always use like var variance.sample because we don't have like the whole stock market data. We always like we are using samples. So I'm going to just double click on this one, where var underscore s. And then again, either you can select all of these rows, or and then go back here, or I could just type TSLA underscore R and hit enter, and then just I'm going to do this, then change this TSLA to KO, and then change this one to just AAPL. So I got monthly average, monthly variance. Now, let's see if we can just do yearly things. Yes, yearly with your annual would be really, really easy. How many months do we have in 1 year? 12. So all I gotta do is to multiply those rows, the corresponding row, by 12. I'm gonna say just 12 times this guy and drag it to right. For variance equals 12 times this guy, and then just drag it to right. Perfect. So I calculated monthly average, monthly variance, annual average, annual variance for each company, and so far so good. Now, remember the goal. We want to calculate first, we want to calculate portfolio return and portfolio variance, yes? So what was the formula for portfolio return and portfolio variance? So the portfolio expected return is this, and the portfolio variance is this, yes? So we need portfolio variance. We need the column vector of portfolio weights, n by 1, its transpose, which we can do it easily with the keyword transpose. But one of the most important ones is this one, the covariance matrix of asset returns. So we have to somehow form this covariance matrix. Sometimes it's called variance covariance matrix, yes. So let's see how we can do that one. So I'm going to call this var underscore covar matrix. And I want to calculate variance covariance matrix. Yes. So again, I have these three stocks. Yes. And then let me just paste it here. And then I'm going to paste it one more time here in a vertical format. So I go to paste special and transpose. So I pasted that in a vertical uh, manner. Yes. Now I want to create this variance covariance matrix. So what is the keyword here? The keyword that I can use is covariance, yes, covariance.s. So I double click on that one, yes. And on this one, covariance of this. So I want the covariance of this series with this guy, yes. And if I hit enter, I get division by 0. Why? Because I have to use something called indirect function. Indirect, if I say indirect, and then enclose this in parentheses, and then this one, indirect, and enclose this in parentheses, and I hit enter, I get that number. So essentially, I'm using this indirect function because when I want to say Tesla on TSLA underscore R, I want the series of numbers to be addressed, yes, not the just letters TSLA underscore R. So I have to use this indirect, and I do this, yes, and I get this one. This is not gonna be working if I scroll this to, let's say, right, yes. In order to do that, here I want to fix the row right here on the first one. So I want it's my second row. So the way I do it is that I put a dollar sign here. And then here for this column, I want to fix the column. So I put a dollar sign before letter P. And then this one is going to be working. I hit enter. I can just scroll this to left and then scroll this down, scroll this down, and scroll this down. And boom, I got variance covariance matrix. How do we know that we have done this correctly? If you do variance covariance matrix correctly, then what happens is that the uh, the the diagonal row would be equal to monthly variances. Look at this one, Tesla 325, monthly variance 325 as well. For Coca-Cola, I got 20.8888, exactly the same thing here. For Apple, 63.61, 63.61. So this is like a check that you can do to make sure that you got your variance covariance matrix correctly. Perfect. That was stage number 4. Now, remember, I need a weight matrix. Yes, I need this n by 1, a column vector of portfolio weights. So I'm going to do this. Initially, I'm going to, so let's call this weights. Yes. And then we have these three stocks. I'm going to start with initial weights of, let's say, equal 3, 3, 3, 3, 3, 3, 3, 3, and then this one, 3, 3, 3, 4. Just initial weights, they are optional. I just want to start with this, and then total, they must add up to 1, yes. So I'm going to just say this, sum of these three, and it must be 1. So these are initial weights that we got. So essentially, I want to change these weights using Excel Solver to maximize portfolio return. Now, good. Now that I got this, let's calculate portfolio for these, let's say, initial arbitrary weights. Let's calculate portfolio return, monthly and yearly, and portfolio variance, and portfolio standard deviation, which we define them as risk. So I'm going to call this portfolio, not single stock, but portfolio. First thing is return, yes. Second thing is variance. Third thing is STD or risk, which we want to minimize this, yes. Now, let's say the first one is monthly. Monthly. Now, the monthly return is just these numbers, weights, times monthly averages. Yes. So I'm going to do this equals. Now we have to do matrix multiplication. How can I do matrix multiplication with keyword mmults? Mmults. And then I'm going to say this. Yes. I'm going to say, so the result should be 1 by 1. So I'm going to say this 1 by 3, comma, this 3 by 1, and I close the parentheses, and boom, I got monthly, uh, monthly return for my portfolio, 2.3.096, when 1/3 of the stock is Tesla, 1/3 is Coca-Cola, 1/3 is Apple. If I want to do the annual, I just do equals 12 times this. Then let me do variance. Variance is a little bit tricky. Yes. Let's review the formula that we have one more time. So W is a column vector of portfolio weights, as we just saw that. Yes. It's three different numbers. I got also V, which is variance covariance matrix, and I need W transpose. So, and this is the formula. So I'm going to start with W transpose and then multiply it by um, variance covariance matrix, and then I multiply that by the matrix of these weights itself. Yes. So the way I do it, I'm going to switch to Excel now. I'm going to say equals mmults. And the first thing that we did was the transpose of this. So I'm going to use the keyword transpose, and then I select this matrix. Yes. And then I'm going to do mmults of this matrix. And then this matrix itself. So I close these parentheses. One more, I have to close these parentheses. And boom, I got 67.08. And if I want the annual variance is, let me review this formula one more time. Again, feel free to pause this. Just make sure that you got this right. So transpose of this, comma, m mults of variance covariance matrix times the weight matrix. And then, so first, this one would be calculated. Yes. Then transpose of this and this one would be multiplied. And then annual is just 12 times the monthly. Boom. Standard deviation is simply square root of variance. So I'm going to say square root of this and hit enter. And I'm going to do this. Square root of, is this one is square root of the annual variance. Boom. So now I calculated return and STD. I'm going to just write risk. So I got the return, I got the risk and everything for a portfolio with these weights. Yes. Now the whole idea is that I want to optimize my portfolio. Yes. Now you gotta tell me what level of risk is acceptable for you, and given the level of risk, I can optimize your portfolio. Yes. Uh, Given the level of so for that I have to use Excel solver. Yes. Excel solver, for that to use Excel solver, go to tab data, and then in tab data, just if you have Excel solver here, good. Otherwise, you can go to tools and then Excel add-ins. So solver is Excel add-ins. And then you can add, for example, analysis tool pack, and then solver add-in, and click on OK. And then you should be having this Excel solver. Yes. So let's see how this one works. Excel solver. Essentially, the set objective, always you want to maximize or minimize something. The thing that we want to maximize is the annual return. So we want to maximize this. And by changing variable cells, what do you want to change? So here I come here and I select these three. Yes. And then subject to the constraint. What are the constraints that we have? Number one constraint, so here you got to add constraints. I click on this add. Number one is that the total must be equal to number one. That's number one constraint, yes. Sum of all the weights must be equal to one. And another constraint that we have is maybe, I don't know, I want not 28 standard deviation of 28 is a lot for me. I don't like that. Maybe I want a little bit less than that. Yes. So I can add something about this, let's say annual STD to be equal or less than maybe another number, 25. Yes. And then I click on OK. Now, if you click on solve, it's going to change everything. Before doing that, I'm going to just, so whenever you do this, Excel overwrites your old values. If you don't want to lose your last data points, you can always do this. So I'm going to close this, copy and paste this, paste special as values. So I'm going to because we want to do this maybe a few times, yes. So I'm gonna paste this, paste special as values, let's say here, because I don't want to lose my old numbers. Yes, I want to have them all here. And then I want to maybe change. Now I want to again do that solver thing. So again, I go to solver. I have the thing that I want to be maximized return. I have here all the weights, and I have my two sets of um, restrictions. You can add more restrictions if you like, and then you click on solve. And it takes sometimes a few seconds, 5 seconds, 10 seconds. It also depends on how many stocks you have. And boom, I got this. So you see, now is keep solver solution. I'm going to say you have the option to restore original values, but you would lose then the new numbers. So I'm going to say keep solver solution, and I click on OK, and let's see what happened. So essentially, if I want 25%, if I want risk to be only 25 or lower, these are going to be the sets of, and I want to get the maximum annual return. These are, Apple should be 56, 0.568, which is 56.8% of my portfolio. Coca-Cola 25%, Tesla 18%. So I'm going to just copy and paste everything maybe here. So, and then I'm going to copy, I copied that, and then maybe I paste it. Maybe I can paste it. And let's say here. So I did, yeah, I'm going to paste special this, paste special as values. We're going to do this a few times. Yes. Let's see. One more time. I want to use this Excel solver. So far we did it twice. Yes. One time with initial weights, one time with this um, level of risk, which is 25. Let's do maybe one more time with level of risk. Maybe let's go even less risky. Yes. So I'm going to change that 25 to maybe only 20. Yes, I wanted to make it less risky. And then I click on solve. And it takes a few seconds. And boom, I got this one. Yes. So now I have less Tesla. Remember, Tesla had the highest variance, so it was very risky. So now I have more Coca-Cola, which is less risky. And I have less Tesla and a little bit less than last time Apple. So that's another like a little bit like safer, I suppose safer portfolio. And I'm gonna paste this paste special this one as values. Yes. And let's do a little bit more risky. Yes. Let's do one more. And so the highest that we had was 28.3. Let me do maybe 35. Yes. Let me do 35. So I'm gonna use solver, and then all I gotta do is to change this 20 to, so just click on change and then change that 20 to maybe 35, a more risky portfolio, and click on solve. And it's gonna take a few seconds as always. And this one is a more risky portfolio. Yes, now I got 42.9. Okay, it updated. Okay, Now I got zero Coca-Cola, 35% Tesla, and then 64% Apple. Yes. And you can always have restrictions that, hey, I don't want any of my stocks to be, the weight of any stocks to be less, more than 50%, more than 60%. You can have those restrictions as well if you like to have them. But so let me just copy and paste that one and paste special as values. And let's do just one more time with even let's say riskier, or you can just try this over and over again. Yes, let's do rather than 35, even, I don't know, 50. Yes. So I'm going to change that to 50 and click on solve. Uh, So what happened? Coca-Cola zero. So remember, Tesla was the riskiest. Apple was medium risk. Coca-Cola was the safest. Now that I am letting Excel to have a risk level to 50, then I got this. Tesla 73%. And I just paste this here, paste special as values. And let me also do one last one, one option that, so that the minimum risk that we so far had was 20. Yes, let's do maybe 15. So one last time, I'll do solver and I change that 50 to 15. So 1, 5, and I click on OK. My expectation is that Coca-Cola is going to be the dominant stock in that case. Let's click on OK, and let's see what happens. Solver. Okay. So the annual, it's so now we got zero te Tesla. The annual risk is 15. Something to keep in mind is that you can't reduce the risk like to whatever number you want. Yes, there is a minimum level of risk. Yes, and maybe that level of risk, it depends on the portfolio. But if I, for example, if I put this 10, let's see what happens. So it kept like this 15.18. So this is the minimum level of risk that you can have. And with that, you're going to have 8.7% return. So that's the very minimum level of risk. So you can you cannot just say like, oh, I want risk of 10. No, there's a minimum level of risk involved with your portfolio. So I'm gonna copy this. Did I copy it? Okay. I wanted to copy this as well. Copy this and then paste it right here. Right click, paste special values. So I did it 5 times. Now I got five different, yes, I did it 5 times and I got five different risk levels. Now that I got five different risk levels, let me just make another table and have all the risks, let's say risk return. And then let me just copy and paste these numbers from the smallest to the highest. So the smallest was 15.8 and return for that one was 8.7. Good. And then this one, so after that 15, then we had risk level up, let's say 20, and with that 20, the return was 19, and then next one was 25, and then here the annual return was 25, and then the next one was 28 as my risk, and the return was 27, and the last one I had was 35 as risk, and return was almost the same thing, yes. Uh, so now that you can see that as your risk increases from 15.18 to 20, 25, 28, 35, your return also increases. I can easily just select everything here and then go to inserts, and I can just put a scatter plot, and I can rename these chart elements. So axis titles, primary horizontal. I'm going to call this risk, which is STV. And then here I'm going to name the vertical axis as return. And, and just make this a little bit bigger to see this relationship. Yes, make so risk return, and then risk return. I'm going to just risk return trade-off. Yes. So we just started from scratch, from absolutely scratch, and we came up with this risk return relationship. So on the vertical, we have return, and on the horizontal, we have risk. Yes. And you can see that as the minimum risk involved with this portfolio is 15.8. And as you increase the level of risk tolerance, and it's not linear, yes, it's kind of a curve. But as you increase the level of your risk tolerance, the return increases. Keep in mind that these are historical return. These are not expected return, not return about future. It's return about the past. That's a very important thing. But we saw that, for if we use this return in the past, the relationship is that as you bear more risk, your return, the circle return increased. Thank you very much, everybody. I hope you enjoyed this lesson. Just I encourage you to do this yourself and get this graph of risk return trade-off. And thank you very much for watching this video. Thank you.